Welcome to our Annenberg colloquium today. We're delighted to have Francois Bar with us. I would like to thank Peggy McLaughlin for serving as our faculty host for Francois, and to Alicia Cohen and Allie Bryant for serving as our student hosts for today. Normally, we invite our faculty host to invite our speaker today when we have our speakers, but we thought we had a rather special opportunity here because Hernan Galpern, who is assistant professor on our faculty, was a graduate student at Stanford University, and Francois was his advisor. So we've asked Hernan if he would like to ask Francois a few questions. No. If he would like to
take revenge, right?
Well, it's a real pleasure to introduce Francois. As Peter mentioned, Francois was my advisor at Stanford in the communication program there, and he's been amazingly productive. He's been involved in a number of different projects, and having worked side to side by him for a number of years, I really mean a lot of projects. And still he had time to be a really great advisor and mentor for all his students. Let me just mention some of these projects briefly that involve Annenberg faculty and friends. Francois is a senior investigator with Peter and Janet in the KDI project. He's also worked with John Aronson in a number of telecom policy issues, and we continue to work together on a number of open access issues. So he's really been involved in a lot of projects with one theme, which is always the theme of the network theory and policy implications of his work. So the talk today is called Open Networks, Theoretical and Policy Lessons from the Internet. So please join me.
Thank you. I'm going to push this down. Well, thank you very much. I was sort of anxious about where this was going with you were giving a chance, but thank you. That was very good. Now, what I'd like to take as a point of departure for the talk is the set of tremendous changes which have affected the evolution of networks in the 90s. And there are really three major categories. One is that we've started in this country and in many other countries to use competition as a way to regulate the evolution of networks, or to govern the evolution of networks, as opposed to regulation. We had in the past monopoly regulation, and we're now using competition as a way to guide the evolution of networks. The second one is there has been a very major change in the technological architecture of networks, and probably the best illustration of that has been the internet and the end-to-end architecture of the internet that pushes intelligence towards the edges, that pushes applications toward the upper layers of the network, and I'll say more about what that means in a moment. And the final one has been the role of users in shaping innovation and shaping the evolution of networks in the past few years. Now, these are events which took place over a long period of time, but they've really crystallized during the 1990s around the emergence of the internet as a dominant network mechanism. In those three trends, the words of open networks keep coming up. People are talking about open when they talk about competition as opposed to regulation, where there's an open field in which many new companies can enter, many new companies can compete with the incumbents. They're talking about open where they describe the physical infrastructure and the technological infrastructure of the internet. You hear engineers using words like OSI for open systems interconnection. You hear regulators referring to similar concepts by using ONA, like open network architecture, and then every country has some derivation of these terms. The Japanese talk about OND and the Europeans about ONP, but there's always an O somewhere, which is this open system. And finally, when you look at what the users are doing, they're also interested in having open access to the network. Now, what's interesting is that even though there is common agreement on the fact that open really matters, that open is good, nobody seems to have to agree on what it means and how open should it be. Is open a binary concept? Are you either open or closed, or can you be halfway open or slightly ajar? What exactly does it mean to be open in terms of standards? You hear definitions ranging from Microsoft, which says my interfaces are open because you can buy them from me, to definitions that you find on the internet which say my interfaces are open because the specifications are fully public, fully published on a reasonable time basis. So there doesn't seem to be much of an agreement on this. So what I thought I would do today is sort of look at some of the projects I've done, some of those that Hernan mentioned, and look at how they together add up to a way to model change in networks. And this is kind of the outline for my remarks today. First, I want to start from a kind of technological insight that looks at what is it that changed about the technology that makes this new model of network change possible. And I'll probably say that several times today, but I want to highlight it here. The first aspect of digital network is the fact that their configuration, in other words, the definition of who can communicate with whom, under which conditions, and to do what, is now independent from the physical layout of the network. And again, I'll get back to this. And as part of this, the fact that control over these networks, control over their configuration, has now become separable from ownership of these networks. And these are two fundamental differences in terms of the underlying technology of the networks. Then I want to move towards some hypotheses that derive from these changes in the technology that have to do primarily with some of the work I've done looking at corporate network users and looking at electronic marketplaces, and that look at how the presence of openness, the existence of these open interfaces, open structures within networks, have created new ways to use networks and have created new patterns of innovation in how people use networks within corporations, but also in how they invent new applications, new network technologies, new network structures, and how this in turn results to a very different dynamic driving the evolution of networking technology. I want to spend a little bit of time talking about evidence, which I've gathered for these various projects. And I'll probably spend my time here summarizing it rather than running you through many case studies, because I had to make some choices given the time constraints. But a lot of that work is based on research I've done over the past 10 to 15 years, looking at how corporations are using networks, and more recently, looking at how electronic marketplaces are being built on the internet. And finally, I'll spend some time in a conclusion looking at the implications of all this. What does it mean? What do these models help us understanding about the network transformation that is underway? And what are the policy lessons? And hopefully I'll do this in the time I have, which may be a little bit of a challenge. Let me start by the technological insight and the look at the technology possibilities. When people look at the transformation of networks over the past few years, they tend to focus on the digital aspect of this transformation. The transition from analog networks, where you would represent sounds and video in analog electrical waves, have now changed towards digital representations where everything is coded into bits. The new networks are all bits. Everything gets coded into ones and zeros. Are characterized by ubiquitous logic in the sense there's microprocessors all throughout them at the ends and in the middle that allow processing and transformation of the information. And bandwidth had become more and more plentiful. It was something that used to be a restriction that with digital is going away. Rather than focus on that aspect of the digital transformation, I find that the most interesting part of this is that as a consequence, as a result of becoming digital, the networks are now programmable. And what that means is that their configuration is written in software. That means that the definition, again, of who can communicate with whom, under which conditions, and to do what, is no longer a function of the layout of the hardware, but is something you can reprogram in many different ways over time. And that means that any given network that might have been designed initially to broadcast one-to-many or to provide interpersonal communication one-to-one can now be reprogrammed to support multiple communication patterns, multiple schemes of communication. What that means also, which is probably the most fundamental point I want to leave you with today, is the fact that network control, which is embedded in this software, is now becoming flexibly separable from ownership. And the two words flexibly and separable really matter here. It's separable in the sense that you no longer need to own the infrastructure in order to control it. And that separability is flexible in the sense that control can be allocated to a variety of parties. It can be allocated to the owners, to the users, to third parties, and that can change over time. So that fact, that transformation in the relationship between control, network control, and network hardware, between network control and hardware ownership, is probably the fundamental change as I see it in the evolution of networks. Let me illustrate this a little bit by reference to some examples from the internet. We used to think of media as 4 different worlds, which I've arrayed here along some traditional categories of mass communication and interpersonal communication, and another dimension which is live or delayed. So either it happens in real time as I'm talking to you, or it's something that happens where the receptor of the communication gets it later than I send it, or what engineers like to talk about as synchronous and asynchronous. So in these environments, we had archetypes of media. We had the telephone as a live interpersonal medium. We had the mail, which was delayed, and often very delayed, depending on the post office system you're using, which was also interpersonal, primarily sending messages from one person to another one. In the live mass communication area, we had television, which was a way to send signal from one person, one point to many at a given time. And we also had newspapers, which was the fourth media industry, which provided delayed mass communication. It's very simple and maybe a little bit simplistic way to think about this world. But what's interesting is that each one was using a very different physical infrastructure. You had telephone companies using a set of copper wires, switches. You had broadcasting television companies using the radio frequencies and using radio waves and configuring them in certain ways to provide this broadcast. You had the post office using something that's really is a packet switch, where it actually switched packets or packages and letters, using trucks and roads and planes and trains and things that will carry messages from one place to another one. And you have newspapers that used a kind of physical broadcast network to print and deliver paper. So you had 4 distinct modes of communication associated with 4 very distinct physical infrastructure, with 4 physical set of hardware. They're also owned by very distinct companies. The phone applications were provided by AT&T, by the Bell companies. The television applications were provided by networks like CBS, ABC, some cable networks, which were an extension of the broadcast network. On the mail area, you had the post office, FedEx, UPS, etc. And finally, you had newspaper publishers in this. So remember these several layers of the argument here. We have 4 different types of communication patterns, 4 different types of physical infrastructures, 4 different sets of industrial actors in these areas. And income of the internet all of a sudden can do all of these in some way. Can do mass communication, interpersonal communication, can do it live, and can do it delayed. Which provides an environment within which you can substitute things like telephone for IP telephony, webcasting for television, and email for mail, or listserv, or some of that equivalent for newspapers. And all of a sudden, the distinctions between the old media sectors start to disappear. Now, just as a way to prefigure some of the conclusions of the talk, that causes problems for policy, because the traditional policies were based on ownership and were based on the physical technologies that were used. So telecommunications regulation is regulation of the ownership of copper wires. Broadcast regulation is regulation of the use of property rights over radio frequencies. And all of a sudden, if those do not necessarily fit with the kinds of policy goals you have, you have a problem or an opportunity, which is what the internet creates. So the internet creates this space which doesn't have the same kind of traditional divisions between either mass or interpersonal, live or delayed. And in fact, what you really need is a continuum of few to few, few to many, many to few, one to few, etc., which don't even line up very nicely in a linear fashion. So that whole graph becomes difficult to argue at this point. This middle space, this kind of bubble that emerges with the internet, has a number of characteristics which derive from its openness. And within that context, open for the internet means a variety of things, but means specifically that the internet really is a software overlay onto existing networks. There's, especially initially, no new wire that was laid out to create the internet, but the internet would take some of the telephone company wires, some of the radio waves from the television broadcasters, ideally would take some of the right-of-ways from the roads and that were used by some of the transportation companies, and would, using software, reconfigure this into a different kind of network that can increasingly support a variety of communication patterns. Those communication patterns, and that's another fact that is really critical about the internet, were essentially invented by the users. And that's a fundamental change, again, from the way in which networks evolved in the past. We used to have a world in which new applications, new ways to communicate were invented by the providers of communication media. Bell Labs came up with the video phone and told the customers that this is new and interesting and you should buy it. The consumers had the choice between buying it or not buying it. In this case, they didn't buy it. But they really didn't have much of a choice in terms of shaping it, changing how it works, changing the patterns of communication it supported. With the internet, we have an environment within which pretty much every application you're using today has been invented by one of the end users, has been created by somebody who was not a provider of the service, but was a user of the network that was made available. And also because this internet is a software overlay on existing network and connects different networks, interconnection between these various pieces becomes the key. So that's one way to understand open within this environment, one way which has been really fundamental to the set of innovation, to the evolution that we've seen within the internet. The second part of this technological insight, which I want to briefly cover, is the fact that if you think of networks kind of in an engineering fashion as a layered system, and the engineers would say you really have 7 layers, and there is presentation somewhere, etc. But I'm trying to make it simple, something I can keep in my head with 3 parts here. All networks have a set of hardware. That's the set of switches, wires, etc. The goal of this hardware is to provide application or services, a phone call, a database query, etc. And in the middle of this, you have control mechanisms, which are ways to tell the hardware layer how to deploy itself to provide the applications. And networks have always been that way. But again, in the past, control was firmly attached to hardware. So in the old crossbar switches of the phone companies, the only way you could invent something like a 3-way call was to take a screwdriver and go down to the basement of the phone company and change the way in which those cogs and wheels and things were attached together, so that when somebody dialed a number, 2 contacts would be made instead of 1, and that would create a 3-way call. With digital networks, what you have is the fact that control becomes separable again. Control, because it becomes embedded in software that tells the hardware what to do to provide the application, becomes separable from the other 2, which means that control can be provided by the owners of the infrastructure, by the owners of the hardware. It can be exerted by the users of the application, and that's what many of the examples I'll describe from a corporate lens represent. Or it could even be provided by a third party, somebody who doesn't own the hardware and doesn't use the application. Companies like Electronic Data Systems have made a big business doing that, providing control overlay onto other people's set of hardware to provide applications that third parties would use. If you think about the emergence of networks today, you have a series of hardware platforms with a series of alternative control mechanisms and a series of alternative applications. In some cases, which are sort of represented by the same color here. They're provided by the same company. In other cases, they will be provided by others. And if you try to overlay on this some of the examples of the players in the industry that we're seeing today, you see that some, like the phone company or AOL, are now providing the 3 layers. I mean, AOL, by purchasing Time Warner, or merging with Time Warner, excuse me, controls the hardware, controls the way in which this hardware is laid out, and provides the application. In the same way, the phone company does the same thing, owns its network, owns its control mechanism, and controls the applications. You have other ways to provide services, which is use somebody else's information hardware network and provide the overlays, provide the control and the configuration of those networks, and provide the applications, which is what many of the ISPs are doing. And you finally have ways to use components that some of the hardware component that belong to any of the network companies, overlay some control that comes from third party, and apply to your own applications, which is, again, what many corporate lands are doing. So as a result, what we create, and to conclude this section on some of the technological insights that come from this, we create a number of new possibilities with these networks. And again, to summarize, multiple networks, multiple physical networks can be interconnected within this environment, again, for this software glue that is in the control layers. Multiple communication patterns can be overlaid on a given network. Network owners are no longer the only actors that can exert this control and shape the way in which networks are configured. And especially today, the end users can control and configure the network they use. Together, these possibilities add up to new drivers for the evolution of networks. I want to emphasize at this point that there is really no determinism in how this plays out. And that's probably something that some of the analysis on the evolution of the Internet has overplayed. The idea that the organization of Internet technologies, because it's a decentralized technology, because it initially started as a grassroots technology, automatically leads to decentralized processes or to more perfect markets, to more perfect communities, or to environments within which the end users are necessarily in control. What is true is that that's one of the possibilities, but in many cases you can actually use the control, use the software to lay it in completely different ways to reinforce control of the existing players. So based on this set of insights, I'm interested in exploring a number of the possible implications and implications for theories that help us model the evolution of networks. I'm especially concentrating on mechanisms that help drive the evolution of networks, and especially those that affect new ways to structure economic activities, new ways to build organizations and get them to function together, and new ways to build markets. The kind of hypotheses that come out of this set of technological observations draw from a variety of theoretical traditions, some from organizational communication, some come more from economics, some come more from political science in some way, but they all seem to mesh very nicely with this open environment that's emerging. The first one is something where probably the leading thinker on this has been Eric von Hippel at MIT, which is saying that if you have an environment like this one, where users start having control over the network they use, then users will increasingly shape the innovation in the network. They will start to drive the kind of technology that gets built in. And especially within the possible range of users, the one we're interested in is what I've called lead users here. So users which have more leeway in shaping their network, who have sometimes more resources, more ideas, more opportunities to do this. And it's going to be interesting at any stage of the evolution of network to find out who these are and how they're shaping the evolution of a network. The second set of insights, which really comes from organizational communication, or for people like Tom Malone from Sproul and Kiesler, is that this process is very much going to be an exploratory process, one that has iterative characteristics, where companies, users will try different things, see what works, see what doesn't, and weed out for this process how they want to change the network as a way to support the kinds of things they want to do. The third one, which also comes from that tradition, is a realization that as a result of these possibilities created by open networks, organizations and networks will evolve together. And here there is a bit of a departure from that ORCOM literature, in the sense that the organizational communication literature is more concerned with how information technology will affect organizations, how organizations will take advantage of information technology. And what I'm really concerned here and very interested in here is the feedback channel. How is it that the way in which organizations use technology will change technology, will change the network infrastructure itself? For all this to happen, the way in which the network is built, is put together, and is architected will matter. Larry Lessig, one of my colleagues at Stanford, likes to say that architecture and code is law. In this case, architecture and code is economics. It's the way in which it structures activities of production, discovery, exchange, innovation, which is really important because, again, the kind of exploration that will take place on networks will then feed back into network technology innovation. And finally, something which draws on some of the comparative work I've done, looking at how different countries have handled the allocation of control, is the fact that in various environments you may have different forms of intermediation, in the sense that end users may directly have control over their networks, or they may have control through a service provider, or they may have control via a PTT, a telecommunications company. And that form of intermediation will affect how effectively they can change the network to reflect what they want to do, and inversely how they can take advantage of network technologies to change their organizations. So here is, again, a sort of a summary of the various ideas and the various theoretical strands I'm drawing on to build on this. And what I'd like to do next is present some of the evidence I've gathered over the years, and present that not so much by running you through it, but more providing you a way to model the evolution that I've observed, and I'll refer to some of the examples. Before I do that, I want to make a small note on the method and describe some of the work I've been doing, which has been largely drawing on case studies of corporate networks and what I've called user roundtables, where I've periodically brought together representatives from these companies in the same room, where I either present them some of the results I found from the case studies and get their reactions to that, or just observe the interaction they have, and then get from that what are the issues that really matter to them. And I found the combination of doing individual case studies and within those companies and bringing the users together to interact and reflect on those case studies has been extremely valuable. And I've sort of kept that up over time with a group that has changed, but that typically has included about 15 to 20 companies at a given time. And I take the fact that I've been able to sustain that for about 10 years as a fact that it's interesting to them as much as it's interesting to me. So that's a way of doing research which I'm really hoping to pursue in the future. And the kinds of companies I've involved in this process are what I thought would be the most interesting lead users in order to observe this set of evolution in networks. Companies like Bank of America, Hewlett-Packard, General Motors, Levi Strauss, construction company Bechtel, some of the technology companies like Cisco, Quantum, PeopleSoft, Solectron, which is a contract manufacturing company, Silicon Graphics, which has had different success over time with some of its networks. And the list goes on. I didn't want to put the entire list here, but more give you a flavor and a sense that I've tried to match companies that do manufacturing with companies that do services, companies that do high-tech with companies that do things that are more low-tech, so they tend to be more users of high-tech than producers. Most of the companies, and that's probably for practicality, have important headquarters or facilities in the Bay Area, which makes it possible for them to come to my meetings, except for GM, where I spent a lot of time traveling through Detroit and Tennessee to visit the Saturn plants, which was pretty fascinating. But so that's the base for the data in many of this. And what I'd like to present today is some observations from what they've done that look at their internal corporate networks, that look to some extent at the inter-organizational network they've set up between themselves their suppliers, subcontractors, and other partners, and finally look at some observations on electronic markets. So let's first start with the evolution of corporate networks. And here I'm using a way to understand what they've done that I've called this evolution cycle, and that draws to some extent on work by Malone and Rockhart that looks at 3 stages of evolution of networks, but it adds a few twists within this, which I'll try to highlight. But what all these companies have been doing in the first phase of adoption of the technology is what I call automation. And it's essentially doing old things in new ways, taking networks to do what they've always been doing, but do it faster, better, cheaper, somehow in a way that improves on the past. During that phase of automation, the organization, the way in which it does work, is essentially unchanged. What changes is the support through which it does the work, the medium through which it does it, or the network that supports interaction between its different members. So the network here is very much a tool for things that used to be done within these organizations. And you can find examples of that throughout these companies. For example, in the 1980s, I spent a lot of time looking at Bank of America that was automating various functions within the bank, automating its branches, automating ATM networks. And when you looked at the way they deployed technology, that was very much in this automation mode, not changing the kinds of products it was provided, not changing the ways in which its employees were providing them, but just using networks as a way to support them. This is, by the way, also something that you can find in some of the more recent intranets of companies, when companies have deployed internet technologies internally, which is what they call intranets. Initially, all they've done is automate some other function, and the function that they've privileged as the first one to automate has been publication. Typically, the first thing they do is put brochures on the web. How to open your 401k, how to buy new supplies within the companies, what are our policies, what are our product descriptions, etc. Again, here, the content doesn't change, the process of producing it doesn't change, the use of the content doesn't change much, but it's just the support for this content that change. This is also something that you can observe in the history of the internet. The very first applications that were offered by the internet were ways to do differently what people had done before. For example, remote login, being able to use a computer at a distance. And instead of traveling to that computer, you would use the network to use it at a distance. Again, you're not doing something fundamentally different, but doing it better, cheaper, more easily with the network. The network here is very much a tool in helping that automation. What happens, though, as a result of this first phase of automation is that companies deploy an infrastructure. They deploy a network. Either it's their own or it's one that they get from an outside supplier. And that's, if you will, a playground or an experimental field on which they can go to the next phase and start experimenting and start pushing the network in different directions, see what else it can do. So, for example, after companies have put in some publications on their intranets, they will start putting interactive forms that help people not only know about the 401k program, but actually subscribe to their investment, or not only know about the purchasing process, but buy pencils over the intranet. Nothing that's really fundamental change in what they do, but something that pushes the edges and that starts experimenting with their technology. So again, without changing the network they put in place in the first phase, they start experimenting with new applications. And at this phase, what you're seeing is marginal changes in the organization, but also in the network. And here is one of these tweaks I announced on the traditional organizational communication approach to this, which is it's not simply changing the organization because technology can do new things, but it's also changing the technology because of what you know the organization needs to do. And I really like the image that Claudio Ciborra has used as a way to describe that, what he calls this bricolage, taking the word from anthropologist Lévi-Strauss, which is a French word that describes putting together blocks of things that have been designed for something else and reconfiguring them in a different way. That's very much what those companies are doing. Now, it's essential to be able to do bricolage that you have an open network. Because if you don't have access to the components that can be rearranged in different ways. So here, the fact that the networks became increasingly open for that period, whether it was the internet or whether it was digital networks that were provided to corporations by various traditional carriers, the fact that these networks allowed outsiders to control them is really what makes this process of bricolage possible. This is something that would be very hard to observe in a pre-digital networks, where you could see the impact of the network on the organization, but much less a direct impact of the organization on the network. This is something that pervades the internet. I mean, if you look at the evolution of electronic mail systems, there is initially the Unix mail that nobody liked to use because it was very cumbersome. So some student at, I forget which university, but programmed something called Elm, which was a mail program, which people at Oregon didn't like, so they programmed something that was called Pine, which is an acronym for Pine is not Elm, which is another way to do email, etc. And people would just reuse components and building blocks that had been set up by others to create their own application. This is also the fundamental dynamic that fuels the open source movement. So this process of invention by taking components that have been put in the network by others and rearranging them is something that is really fundamental to this new network evolution process. So what usually happens is that after experimenting for a while, these companies run into the limit of the initial network they had, that they had put in place at the automation phase. And what they need to go further is to change the technology itself, to reorganize the network. And here the network becomes a way to articulate change in the organization and also to articulate change in the technology itself. So there's this joint process. And probably the best example I found of this in some of the early case studies I did was the way in which Hewlett-Packard was one of the early users that shaped virtual private network offerings from ATT, which is an environment within which Hewlett-Packard was really interested in deploying concurrent engineering design capabilities, having people in 15 different locations across the globe work together on a similar product by coming together and hooking up their CAD systems, and couldn't do it because that requires some very extensive networking facilities, and they could not afford to maintain those facilities permanently for everybody. What they did was come up with an agreement with the phone company, which was still mostly ATT at the time, that ATT would allow them to directly control the network, to grab some resources when they needed them, and put them back in the network where they did not need them. One interesting analogy to understand this, it's like a timeshare condo, where for the time you use it, it's yours, and then when you don't need it, you put it back in the public pool and somebody else gets to use it. With networks, again, because the control of how that's allocated is in software and is now separable from the hardware, that becomes very easy to do. And it was possible for HP to grab that facility and put it back in the network. Now, the way in which HP wanted to reorganize its design process was essential in understanding the way in which these new telecommunications products came about. And so you have here a really good example of that feedback channel where organizational change is suggesting new ways to articulate the network, new ways to new processes of innovation in the telecommunication network. Now, what happens at the end of this reorganization phase is that the company finds itself with a new network or a new configuration of a network and can start again. So you have very much of a cyclical pattern with several successive generations of evolution of networking. Just as a way to illustrate this with an animation here that the networks, the cycles will tend to build on one another. So what you have here is fundamentally a very, very simple model of how networks change, but which has tremendous richness in understanding the forces that shape the evolution of networks. Some of the characteristics and some of the features of what's happening here include the fact that it's an iterative process, and that sort of fits some of the initial hypothesis that I started from in trying to examine what I was saying, it's a process that's cumulative in the sense that innovation that gets generated by one of these cycles gets built into the network and is being used in the successive rounds of evolution. It's a process that's end-user driven, which means that the providers of the network take a back seat in shaping this evolution. It's a process where there is structured learning. What you can find out depends on what network and what network structure is available for you. Knowledge becomes embedded within the network because it reflects some of these processes you've discovered. And there is a very strong path dependence to this process in the sense that where you start and how you evolve really matters to where you end up and to the outcome. In sort of slightly less pedantic way to say this is that history matters in this evolution. What you're seeing also is the fact that networks and organizations do co-evolve in this environment, that the organization will change, but the network will change also. And the relationship between the two is important. Probably the fundamental mechanism of this has to do with the network flexibility. And especially two kinds of flexibility within this environment, something that I've called applications flexibility, which is the way in which organizations were able to deploy new applications on a stable network without changing much about it, which is really the automation and some of the experimentation phase I described. There is a very faint cycle that you can see behind these words, but it doesn't quite work. And the second one being the configuration flexibility, which is their ability simultaneously to take advantage of the network's possibilities and to change the network to reflect what they know of the organizational possibilities. Interestingly, if you go back to some of the technological insights from the beginning, application flexibility is something that only calls on the application layer. You know, the network stays the same, and all you do is lay out new ways to use it. An easy example of that would be once you have a phone network, you would design a fax network by not changing anything to the numbering system, the way in which you connect people to one another, but you just change the machines at the end of the system. By contrast, configuration flexibility requires that you involve the control layer and the hardware layer. So it's only possible once you have some way for the end users to access the control aspects of the network. A series of other insights come from evolutionary economics and some of the work of Nathan Rosenberg, for example, looking at who learns within this process. And again, if you look at the first phases of automation and experimentation, the learning that happens is mostly by using the technology. It can be applied to your own processes. By contrast, here when you need to change the configuration of network and get your hands dirty with the control features, you learn by doing. And these two are very different kinds of learning that result in different kinds of knowledge within organizations. And one of the big changes that has happened with this evolution from analog to digital network is that they can increasingly be combined. That traditionally, learning by using was for the user and learning by doing was for the network provider. Now that control is separable, now that those networks are open, the two kinds of knowledge can be combined and help in shaping this evolution. I'm going to try to speed up a little bit here to make sure I fit with my time here, but just show here that over time, as you follow those organizations and as you see them go through for a variety of cycles, you can trace different generations of networking technology. That in the 70s to the mid-80s, everybody was using a public network. Then progressively they start using private networks. Then they're able to combine their control with some of the provider's control and create what they've called hybrid networks. And they now move to what I've termed here web portfolio, which is a combination of intranet, internet, extranets, etc., the various names that companies have used to describe the various networks they're using. I want to briefly look at how similar kinds of analysis can also apply to electronic marketplaces and to the world of electronic commerce. And that sort of do a flashback on what e-commerce was promising us about 6 years ago. And you may remember this at the beginning of the dot-com era, that entry barriers would be shattered, that anybody could just set up shop on the internet and start being in business. That you didn't have to be big to that. Small was beautiful and powerful. You may remember those IBM ads with the kid and the lemonade stand that was lemonade.com, and all of a sudden they were as big as Snapple. A world in which you would have disintermediation, that you didn't need any brokers between the buyers and the sellers because they were connected to this network and in direct contact. And we would have a frictionless economy, and that's a word that Bill Gates has used a lot, where there is no transaction cost, that everybody knows everything perfectly, instantly, and therefore exchange happens in a way that mirrors the perfect market and the ideal of economist. So far, if you look at those 4 areas, it's not quite happened in that way. It turned out entering was easy, but what was really hard was staying once you had entered. It turns out that small may be beautiful and powerful, but if you look at the environment today, large players tend to dominate. And that's true of many areas, of the hardware, of the application, of the software. Anybody can be a bookstore on the internet, but there's really only one that starts making money. Anybody can provide networking equipment, but there are just a handful of companies that are successful at it, etc. Also, in terms of disintermediations, what we've seen is that new intermediaries have emerged rather than disintermediation. We've seen electronic brokers instead of traditional brokers, new travel agencies on the web, that new business-to-business marketplaces that provide intermediaries between different business buyers and sellers. And finally, this friction-free idea turned out to be a very slippery notion. As a civil engineer, I tend to think that friction is what makes the world works. That if you don't have friction, you just slide around, you can't stand up. And in fact, it was actually interesting to see for the various business plans that came out of the Valley, that one of the key words you kept finding was called stickiness, by which they referred to their ability to grab customers and prevent them from going somewhere else, which is a nice counterpart to frictionless. Stickiness is not friction-free. As a way to understand what changed and sort of relate that to the open network idea, I think it's interesting to map e-commerce and to see what various things people have described as electronic commerce. And typically, if you think about commercial activity, you usually have a set of infrastructure and a place where people meet in the market. Then you have a marketplace, which is very much an institution, which has rules of how you enter, how you interact with other people, and what results from that. You have a system of transactions and payments that helps in the negotiation and in the transfer of goods or services. And finally, you have things that get delivered through this marketplace. And if you think about conventional goods, you had a set of conventional marketplaces which vary from the central squares of medieval French towns to Covent Garden and places where people come and exchange, and what they do is exchange conventional goods. The first step of electronification, if you will, of this environment is to provide an electronic support for the infrastructure. So instead of having to physically come to the marketplace, you can call and find out what the prices are. But again, the marketplace really doesn't change very much. What really changed with the advent of internet commerce and some of the internet network marketplaces was the fact that the marketplace itself became electronic, even when it still delivered conventional goods. And in the kind of idealized and ultimate version of electronic commerce, you have environments within which the goods themselves are electronic. And we've called all these things electronic commerce, but they really vary tremendously in terms of how the network is structured, how control over the network is exerted by the various players. And just to summarize this, I wanted to show, first that what I think is the fundamental aspect of this is the transition from conventional to an electronic marketplace, but also summarize what's not so new about this and what's really new about this environment. What's not so new is very much in the flavor of automation. It's just doing better what marketplaces have always done. You get better flowing market-related information, faster matching of buyers and sellers, speeding up of transaction, the money flows faster, you reach new customers, etc. None of that is fundamentally new about ways to organize commerce. What is really new has to do with this picture, which is the central square of Pontoise in 1876, which is the marketplace. That's the name of that picture, that tableau by Ludovic Piet, which is to me the best illustration of what really matters about marketplaces. You see here that you have first a marketplace which is bounded. There are buildings around it, so it means that there are some limits to how many people can be in it and participate in this environment. You see that there are different kinds of places where they show their wares. There are some which are exposed to the element, and if it starts to rain, they'll be in trouble, and some over here have more protection. You see that you will define some discovery path for the buyers as they wander for the stalls and see first those tomatoes and then those tomatoes, and that will affect the way in which they buy. If you've got good eyes, you can even see a barrier at the back here, and a few policemen that are keeping the buyers out until everything is set up for them to come in. So you see a number of features which have to do with the architecture of this space that affect the way in which the marketplace functions. And the claim is that today the network is that marketplace, and that those architectural features of the market are what's embedded in the control layer of networks. The network now becomes the place where all the fundamental processes take place, process of discovery, what's out there and how much does it cost, matching, I'm the buyer for that batch of goods, negotiation, how much you're willing to pay, transactions, and in many cases delivery if the good itself is electronic, whether it's software or music, etc. And what happens is that within the environment where networks can be controlled and configured, if the network is the marketplace, then control over the network determines the marketplace architecture. And that's really what has happened, and what's in evidence behind the fact that we never saw full disintermediation, full frictionless economy. What happened was that anybody who had a stake in this marketplace tried to embed these stakes through their control over the network that supported this. By software, they defined who could play, who are the buyers, who are the sellers, who are the third parties in this environment. They would define whether they have equal or non-equal access, what would be the rules, whether it was an exchange with bid-ask mechanism or auctions or brokerage, etc., whether it was level or biased, whether some of the players had more of an interest. And here, control of the network, so the fact that the network technology was open, allowed some of the players to get control over the configuration of the marketplace, and as a result to get market control, which is a fact that has been sort of overlooked by many of the analysts of this environment, but again, which is something that explains how the technology shaped the organizational and the economic processes that are used, that use the infrastructure, and inversely, how those processes get to shape back the infrastructure by creating incentives for the market players to embed certain kinds of control in their marketplaces. What they've done is create multiple kinds of marketplaces. And here, again, is some of the data. I'm just summarizing quickly, but the way in which the auto industry, the GMs of the world, or Dell have been doing it is just reinforcing existing relationship, whereas we've had very new kinds of marketplaces that triggered the development of peer-to-peer technology, and Napster is a good example of that. But some of the content syndication companies in electronic publishing are another example. Some of them aggregate biopower. Some of them are creating walled gardens where only a certain set of providers are allowed to enter. Just as a last comment on this, it's been interesting to observe that over time and to look at the way in which airline reservation systems, which are really markets for trips, have been evolving. That initially, American Airlines created a very closed system called Sabre that it offered to travel agents, where strangely, no matter where you wanted to go from and where you were trying to go or what time, an American airline flight will always come first. They had control over the configuration of that market and therefore used that towards market power. The antitrust department caught up on that fairly quickly and told them that was not okay, forced them to reconfigure Sabre as an open marketplace in which they started to charge entry fee to airlines and car rental companies, discovered they could actually make more money this way. So it was almost a serendipitous benefit from this. There was a time where Sabre was making more money than flying airplanes around for American Airlines. It looks like flying the airplanes was the excuse for running the marketplace. Then enters the internet, where you have direct sales from the airlines to their customers, multiple marketplaces, the emergence of Travelocity and Premier Travel, etc., which lasted for a very short period of time, where you had something that looked more like this disintermediation. And what we're seeing now is that Sabre has bought Travelocity, which had bought Premier Travel, and Orbitz, which is a marketplace set up by a consortium of airlines, is basically trying to get the whole game. So we're seeing almost a full cycle from a closed system to experimenting with open systems to reclosing the system or controlling it. Again, all these different ways to structure these marketplaces reside in the ability of the players to control the network. And the control they have over the market derives from their ability to control the configuration of the network. Let me conclude briefly with two slides about what this really means. I think one of the, and really what this is an outline of my research agenda for the coming years, or maybe decades. I think it's a big enough one for this. One is that the user-driven process of innovation, which I've described in those two instances, but there are many other instances that can be found, is now really a core driver of network change. And that's something that needs to be better understood, because there are many ways in which lead users will shape network technology in different environments, which will affect how the networks as a whole evolve at a very macro level of the national infrastructure. The second aspect, the second implication of this is the fact that organizations, economic systems, whether they're internal networks, corporate networks, or marketplaces, will co-evolve, and that the change in the organization is accompanied by change in the networking technology. And again, the process of coevolution is something that needs to be better understood, which I'm really hoping to get more insights through this KDI project we're involved in, and that's one of my personal interests in this collaboration. What's interesting to me as well is that this is true at various levels. It's true at small group levels within companies. It's true at the firm level, at the filière level, as we say in French, with firm clusters, or markets, or at the level of national economy. You find this co-evolution process with different scale of actors that take advantage similarly of the separability of network control. And within all these environments, the architecture of network really matters because it defines economic control. It defines the processes of innovation creation and diffusion. It defines who can learn from this experience, who can transmit learning, what the level of intermediation will be. So it has tremendous ramification in how the economy that rides on this network will be organized. And to me, that's where the fundamental policy issues are residing at this point, in how will policymakers define access to control, and how will they define, as a result, the architecture of networks. So just to finish here, the kind of policy implications that I see here are first very pervasive, in the sense that this is a generic problem. You can actually read the entire Microsoft antitrust trial by thinking of Windows as the control layer of computers, which is a definition of certain application programmer's interface. How do you interconnect with the operating system? And as a result, who gets to control the innovation process? Should it be fully Microsoft, or should it be outsiders who get to play and plug and control their piece of the physical hardware to deploy new kinds of ways to use computers? It's something that is also a way to understand the broadband internet access debate that has sort of died down a little bit, but has been very active over the past 2 years, in the contrast between DSL regulation and cable modem access. And I'm happy to say more about this. It's something that matters to the evolution of interactive television, as Hernan and I have worked on. Just finally, I wanted to highlight the fact that it's also fundamental to the evolution of wireless here, where the wireless industry tends to treat spectrum as property and as designed property rights that allow the owners of the licenses to control that spectrum and to control the way in which it's been deployed, and to control everything that's in the vertical stack on top of this. So if you're Verizon and you get a license to provide cellular networks, you get to define how that frequency is being packaged and used. You get to define the applications that ride on your cell phones, etc. There is no openness here, except in a few niches. And one of the niches I'm really interested in exploring is the Wi-Fi set of technologies, the wireless LAN technology, which uses unlicensed spectrum to see how else this could be organized. What that creates is a series of dynamics that are very reminiscent of the very early days of the internet, with grassroots sponsored evolution of networks. As a result, allocation of network control becomes the key policy issue. It is something that policymakers have not fully grappled with. They've been used to deal with ownership and hardware. So the kinds of rules that came out of that is how long does it take to depreciate telephone equipment? How do you set up the shape of the plugs that people can connect to in the walls, but not how do you define the rights of access to the software of the phone company, of the cable company, of the satellite company, etc. This was one of the issues that was behind many of the computer inquiries in the 1970s and 80s. This is an issue that also was behind the discussions on the Communications Act of '96. This is an issue that still hasn't been fully resolved and that gets looked at in very different ways in different countries. And finally, just as a plug, my personal bias on this is that unless the networks are open, we're giving up a series of ideas and a series of innovation processes that really should be brought into this process. So apologies for being a little bit too long, but I'm going to stop here.
Well, you weren't so long that we don't have a little bit of time left for some questions and discussions with you. Feel free to sit at the table if that would be more comfortable. And who would like to ask a question or make a comment? Yes.
Your conclusion on the key is the allocation of network control. And it brings to mind a historical analogy, the story of the Three Musketeers. And we haven't really thought about that as a communication problem, but that's what the whole story is all about. Can you get a message from A to B or a parcel from A to B without the seal being broken or that it's not intercepted? And one of the characters in the story is the Cardinal Richelieu. It turns out that the Cardinal Richelieu is recognized as the founder of the National Postal Services. That is, there had to be a government role on unregulated roadways, multiple carriers. There had to be a governmental role. So when you say that this is a policy, it's a political matter. So how do you envision the fact that since intranets are possible, why can't there be a government-run intranet that gives us the kind of security of sealed letters, postmarks, and all this sort of thing?
That's a great question, and I mean, first the postal analogy is interesting in the sense that once the infrastructure for the postal system is in place, it doesn't necessarily have to be controlled by the post office. And there has been a number of experiments and a number of ways to think about this, mostly in Europe, and actually Switzerland has been at the forefront of some of these reflections of the extent to which you could deploy a virtual private postal system onto the government's postal system. So having somebody use the infrastructure but control it in different ways. In a way, that's what Federal Express provides to its business customers. Dell runs its logistics largely through Federal Express by using Federal Express systems of transportation and airplanes and storage as a way to overlay their virtual private logistical system. So in this sense, you're right. It's not a new question, and you can go back to Richelieu in this. The second issue, which is what does it mean in terms of defining a new role for government? What you're really advocating here would be nationalization of the entire telecommunication system, and then
carriers would still be allowed. I didn't mean to imply that they would be the only electronic carrier, but that they would be one that we would know had certain virtues, steel letter notions.
Yeah, I think it's a really interesting proposal. It's one that not to be discouraging, but it's probably not likely to be considered in this country in the near future. But it is one that I think would be interesting. That one of the issues that resonates with this is many of the telephone companies, the local carriers, have been thinking that unless they're able to provide more advanced services, there was no interest in them providing just carriage and providing just plain pipes. A network with higher reliability for encryption or privacy or security or whatever matters, and then let others compete with that on features, but also make it open enough so that somebody could overlay their own structure of delivery on this network. Again, I think that's a very appealing way to think about this. I also think politically it's one that probably doesn't have that much future, unfortunately.
Yes.
In some internet cases like Napster, it seems that the attempts to control the marketplace are taking place still on the social level, particularly law, and rather than directly controlling the architecture level. I wonder if you see that changing, whereas enforcing certain policy decisions will take place by changing the architecture itself, rather than just forcing people to do things through the law.
Yeah. Again, my colleague Larry Lessig spends a lot of time discussing those issues. Yes, I mean it's definitely a trend of trying to embed control and trying to embed some of these what used to be in this environment purely software possibilities into some of the hardware, and the way in which, for example, some of the copyright discussions are trying to change the technology itself to prevent this experimentation. I think it's a loss. I think it's too bad to ban a technology because you don't like certain uses of them, and I think it's probably more profitable in the end to try to expand the range of experimentation and then deal with the specific outcomes that you think are unlawful, and then still deal with them with law rather than with code or with hard-coded code in hardware. But I agree with you that that's been increasingly a trend of trying to build in the mechanisms of control of intellectual property, of freedom of using the information within the hardware itself, as a way to make sure nobody can change that allocation of control.
You pointed out to the role of the key user, and they are able to change the configuration of the networks. And most of the time that brings to patterns of power that restructure itself, as in the case of the airline industry that you mentioned. So you talk about the role of the policy in order to balance these issues. But on the other side, those key users are most of the time the people that are able to influence policy. Because they have a lot of power. So I was wondering if you could...
Well, yeah, that brings in an interesting point, which I didn't take the time to make, but I've picked those lead users, those big companies, big corporations, because in a certain time of the evolution of these networks, they were the ones who had the ability, physically, because of their resources, because of their power, to start changing their network. One of the promises of many of the networks we're having access to today is that power can be decentralized, or that the ability to shape the network no longer needs to reside only in big actors. But as you're putting it very, very nicely, this is really a political decision. It is not something that derives from the technology. So the political decision has to be to create openness within the network, as opposed to encouraging closeness in some of these networks. And to me, that's probably one of the most fundamental issue in the DSL and cable modem debate, where, as you know, cable modems have been regulated like the cable industry, in the sense that if you own the cables and you get to control the kind of information services that are delivered over this cable. So AOL gets to define which ISPs are provided over Time Warner's cable and what kind of applications they can do. By contrast, traditionally in the telephone environment, we had regulations that forced the phone companies which own the wires to become carriers and to let any ISP, to let any provider of information use those wires to do whatever they wanted. Now, in this second environment, you create all kinds of possibilities for innovation by some of the small users. For example, I mean, just to take something that's very simple, over a DSL connection, you're allowed to run a web server. If you're getting a cable modem in broadband internet, you're not allowed to do that. That's prohibited by the acceptable use policy of the cable company. That's a way to limit innovation. That's a way to prevent innovation by some of the end users, which may not be big corporations. So I'm afraid that the trend we're seeing today towards consolidation of ownership in many of the media, and at the same time allowing those owners to get increasing control with the configuration of their network precisely goes in that direction, to let some of the more powerful industrial participants control the evolution of these networks. And this doesn't have to be so, and there's nothing about the technology that prevents an alternative route.
Yeah.
Okay, we have a couple more questions. So
I just want to comment. It seems also that a network control that's completely at the hands of the end user would also discourage capital accumulation. And at some point, you need to have some incentive there for the creation of new networks. If everything is totally open, where is the incentive?
Well, that's the argument the cable industry has been making, of saying, if you open our network, there is no incentive for modernizing the network. There are two kinds of responses to that. I mean, one of them is some work that's been done by Jeff McKee-Mason at Michigan, where he's actually come up with a really interesting test case, which is a comparison between the U.S. and Canada, where in Canada there are open access requirements on cable and not in the U.S. So it's almost the perfect experimental setting where you have very identical countries. I mean, that shouldn't overstretch this, but but by and large, a similar kind of dynamics and one difference in the regulatory regime. And what is shown is that there has been more investment in modernization of cable systems in Canada than in the U.S. within the same period. One of the reasons for that, which is the second part of the answer, is that yes, maybe initially you get less control over what you know how to do, but you get to encourage experimentation and discovery of new things that you don't know how to do. And those applications may end up being the ones that create most of the revenues. And they create, if nothing else, more traffic on these networks. So there is one piece of data to look at this and one kind of hopeful strand of analysis to look at the future.
one final question.
You've mainly referred to market players when talking about control and dissemination of control. If we break it down to a lower level, how or where do you see possibilities in order to disseminate control to the actual end user in terms of participation and democratization, especially in light of ICANN's recent statement that basically governing without governments has failed.
Right.
You somehow have to come back to a system where the government step in and not the user itself is empowered to do so.
Yeah. Well, let me try to reframe the question a little bit. I mean, having government step in, I don't think is a way to disempower the user. And in many cases, government stepping in is the required condition for empowerment of the end users, because government finds itself in this environment as the only actor that can enforce openness at the control level on some of the networks. Again, let me go back to the DSL cable modem example. Imposing through government policy requirements on the various carriers so that they can open their networks is a way to empower small end users and not just market players or marketplaces to get some control over how they configure their networking environment. So in that sense, I don't see an opposition, as you were putting it, between the interest of the end users and government. I see more of a synergy in ways in which government can create the conditions of experimentation and participation by end users. I'm not sure that answers quite the ICANN question, but that's another ICANN of worms, I guess, if I can say this.
Well, Francois, thank you very much for coming down, giving us